Test. All right, there we go. Hey, cool. Thank you for coming to the VV meetup. I hope you had a great festival so far. I hope you're feeling exhausted. I guess that's what you should do after so many days of Ars Electronica this year. And I hope also that you're gonna enjoy the night tonight. So we're gonna host a very special meetup today. It's basically, usually it's like every month, but this year we're gonna, or this time here, we're gonna do like a VVV meets Ars Electronica meetup. So that means that through the night or the next couple of 2 hours, we will basically go a bit more into a tech talk, so to say, about a couple of projects that are here being exhibited at the exhibition, which are being made on the one hand with, let's say, tools like, you know, Touch Designer and ESPs and things like that, but also on the other hand with VVV. And I guess some of you don't know what VVV is, so I think we also need to give you a quick introduction to that. So I hand over to Amir.
Hi, good afternoon, evening-ish from my side as well. Welcome to another event at the Ars Electronica. Just so you know, there are 600 other things happening at the same time. So some people are asking, which one do you recommend? I really don't know, but it's good that you are here. So what is VVVV? I don't exactly know what does it stand for, and I would also like to keep it as a secret. Not that I know about it, but it's good that it's a mystery. But VVV is a software that you use to program things, simply said. It's been used by the artists, by scientists, by programmers, and now it has its own, since I think 5-6 years, it has its own programming language called VL as well. It's similar to C#, if you know C#, but you have these visual components that you click and connect together. We call them nodes. And but VVV is not only a software, as we are proud of, it's also a community, and that is a really important aspect of VVV. It has its own famous trust-based licensing, so it's a fair use, so you can just download it and use it, but the developers, they trust you. If you earn money, you just share some of them with the others who are behind VVV and building it. If you have been in the Ars Electronica, whether in the Post City or here, I'm 100% sure you have seen works that they are done with VVV, whether you noticed it or not. It has been around for more than 20 years now, and we are hoping that it will be another 200 years around as well. So I mentioned that something about the community. That would mean, as also Simon pointed out, we are going to see some projects that they are not necessarily done in VVV. But what is important for us is the spirit, the community, having people around and sharing things and learning from each other, sharing things with each other. So we see some of the works that they are also not necessarily VVV related under the hood. Somebody asked me when we were sharing on social media, somebody asked me, why did you tag Touch Designer on a VVV meetup? And I was like, why not? I mean, this is something that we would like to do. We would like to see other minds and people around. We have a lineup. I'm really proud of this projects that you're going to see. We have, like, I always call it 6+1. That means whenever we have a meetup, we always would like to keep a tiny spot open. Maybe someone is just around. He or she didn't tell us before. We don't even know them, but they are here and they would like to show something. And we always keep a tiny bit of a spot available for someone who just want to jump in, put the computer here, and spontaneously show something. That is the +1 that I talk about. One thing, speaking about this +1, and what is very important for us is time. I'm going to be a little bit rude. That would mean I'm going to remind you when your 50 minutes is over that you need to basically try to wrap it up. If we are very much on time and we can keep the track of time, we could have a comfortable meetup, we could have a comfortable presentation, and perhaps adding more to the back. So without further ado, we have the first one. The first presentation is called Elon, and I would like to ask whomever is going to present Elon, coming here with their computer.
Greg and Florian, please come on stage and present the Elon project.
Yeah. And while do you have the Zoom link and everything ready?
Sharing.
Perfect.
I don't know why it's not there yet.
That is, Simon should go there. Somebody should always work in the background.
Yeah. Good. Hello, everyone. Thank you for having us. My name is Craig Campbell. I'm on the, let's hide that. Sorry. There we go. My name is Craig Campbell. One of our colleagues, Randy Lewis, is stuck in an escape room in Austin, Texas with COVID and Elon. So we have the Randy Lewis doppelganger here, Jessica, who will be speaking for him, followed by Florian, who is also a colleague. So the three of us have been working on this project, and we're invited to collaborate with Simon Weckert. So without further ado, we're going to introduce our project to you. We're mostly going to be reading to you because we're anthropologists and we speak much too long if we don't stay on script. So we're going to be reading some sort of choice bits of writing for you.
Hi, everybody. Yes, my name is Randy Lewis. Here we go. Elon is a performance of cool agency in the age of panic. There is a calm vibe in our Ars Electronica rooms, our video, our magazine. We are walking in an electric culture of frenetic nothingness. We offer a sensory experience. Pour a glass of wine. We invite you to savor its bitter notes of ironic urgency and Dada anarchism. Taste the terroir of Texas and Berlin. Enjoy our piquant blend of old and new world reds with an undercurrent of K-hole bliss and nonviolent pew-pew culture. This is the house of wine of the show Severance and the love child of Eric Andre and Karl Marx with Cool Whip Lube. It's a passive-aggressive shrine to a god we refuse to worship. A bloated god with no love for his creation. Our installation with Simone is a quirky way of staging collective engagement and inviting contemplation of the dominance our techno-feudal lords have over our lives. We are joyful digital peasants with pitchforks. We are monkeys in the shadows of the jungle temple that looms over our lives. We are scurrying on the ground beneath the cloudalists, looking for places to conspire, feast, plan, and mate. Thank you. I am Randy Lewis.
Thank you, Randy. As Elon started to dominate our algorithms, we followed him into the corners of the internet, where the tech bros and the gigachats rule. At the time, in 2022, Elon's role in the broad public was to be the mouthpiece of a tech-driven, sci-fi-indulging fanboy community that seemed to be mostly fascinated by the messianic omnipresence of Elon on all media channels. Hyperfans created the Elon Goat token, molded their rocket Jesus into a bigger-than-life stainless steel statue, a Elon-headed goat riding a rocket, hauled it all the way from Phoenix, Arizona to Austin, Texas, and waited for Musk to step out and accept the sacrifice. He never claimed it, though. At some point, Elon made us all look towards Mars, a new frontier, a new chance for interplanetary colonial extractivism, although the moment never came as promised, where we would set foot on Mars. Elon's hype did not fade. On the contrary, it grew. Such over-the-top fandom dispersed all around the globe needed an outlet that it deserved. That is why we started working on the Elon magazine, the magazine for best billionaires. As scholars from different academic fields, we engaged in a non-maintenance of disciplinary boundaries. A new phenomenon that is tech capitalism invited new methods, which may strike some as irresponsible or even some kind of absinthe-fueled fantasy, but we see it as a quite serious form of intellectual play. We want this to land in a particular way and have some anxiety about getting it right. Or, as the poet and writer Edna St. Vincent Millay put it, a person who publishes a book willfully appears before the populace with his pants down. If it is a good book, nothing can hurt him. If it is a bad book, nothing can help him. So we appeared with our pants down while giving Elon a wedgie. The magazine as a critique might be barely felt by Elon and his lackeys, but as it circulates, it seeks to create new angles, new encounters with Elon, and new points of critique. With a lifestyle magazine, we chose a media format that is ephemeral and versatile. It leaves the possibility for gaps, for loose threads. The format hints at a series. That is why we thought about releasing the first issue actually as number 5. Self-publishing allowed us to create our own styles of writing, referencing, and layouting. A second issue might go in a different direction. In fact, we are moving away from AI-generated content and ask for handmade digital collages that draw from the pile of images that already exist. Today, we have to deal with XAI, Grok, a highly surveilled media platform like X, and Elon as a steadily chaos and panic-inducing subject. He evolved into a personification of crisis. To deal with our collective insecurities, the overwhelming presence of Elon, and the public chaotic environment he created, we have thrown ourselves into a form of academic delirium, panickingly creating AI-generated imaginaries of Elon in the most banal settings of everyday life. This delirious scholarship let us realize that what academia sacrifices when it becomes excessively sober is the spirit of play that enables new forms of invention and insight. Maybe a way to counter the panic was to enter this stage of delirium, of throwing the soberness overboard and engaging with the reality in an activist, satirical, and artistic way. We have dubbed our own playful take on the procedures animating our collaboration Degenerate AI. In this sense, we feel some kind of joyful, corrupting influence on the innocence and sincerity of AI industry striving towards seamless fakery. We saw it as an anarchist twist on the AI hype machine. The artist Marta Rosler once wrote, "If material conditions need to be redescribed more painstakingly and in novel forms in order to be reinvested with believability, then we can surely develop the forms and the means of dissemination to do so." In this sense, we imagined our AI work as a form of ecstatic truth, a term coined by Werner Herzog, that seemed very fitting for our project. Quote, "There are deeper strata of truth in cinema, and there is such a thing as poetic, ecstatic truth. It is mysterious and elusive and can be reached only through fabrication and imagination and stylization. Perhaps reality has to be stretched to a point where it almost rips apart to expose its lived cruelties, indifference, inequality, structural violence, etc."
Panic. In the end, we have a series of little panics. The first is the one that initiated this whole project. While conducting much more sober sociological research on the placement of the Tesla factories in Texas and Germany, we were heavily distracted by the antics of Elon Musk. But let me tell you about some of the others. Most of us seem to wallow in a series of little panics, not the ones that lead to therapy or forced sedation, but the low-level ambient panics that are all around us, that come and go in their intensity. Such panics are the recognition of something that might be physically or morally dangerous. How many innocent civilians have been murdered by Israel today? Are they still using lavender to create kill lists? Will I still have a job in 5 years? These are big consequences of little panics. But there are other little panics, less immediate ones, that are about our apparent lack of agency to do much of anything about it all. We are constantly being solicited for emotions we cannot master, placing us in impossible conflicts with ourselves and with others. Overall, the morass of little panics includes for us the social and environmental impact of the computing power necessary for large language models to generate the images in our magazine. Offshoring moderation and cruel labor practices, Tesla's experimenting with unregulated automated taxis in urban settings, the collapse of journalistic integrity and models for authenticating documentary image. On top of it all, it seems every other day a thirsty new data center opens. It seems every other day that obligatory AI worms its way into our lives a little more. Another little panic we see is one over the instability of forms. The photorealistic images created by today's AIs are haunted by a pernicious delirium. These, you know, are called hallucinations. For those of us in the art world, the hallucination is enticing. It promises the destabilization of passive assumptions about the autonomy of things that it turns out really aren't so autonomous. There is yet one more little panic over the too muchness of the spectacle. The magazine seemed like the right response to this overwhelm. While Guy Debord's spectacle may have become something of a tired concept by the 1990s, more than ever it seems prescient in describing the contemporary moment. Perhaps the spectacle has really reached its conceptual apotheosis in the figure of the stack, that accidental megastructure that Benjamin Bratton describes. Computation has become the form and the content through which we organize our ideas, economies, and cultures. It is not only a way in which governance operates, it has become governance itself. And so the spectacle, after all, isn't a collection of images. Rather, it is a social relation among people, mediated by images. And the stack, as a multi-scalar accident, isn't an assembly of apparati, but rather relational processes mediated by the composite armature of computation. I'd like to finish by inviting Simon to talk a little bit about our collaboration and his participation in it.
Yeah, thank you, Craig. So yeah, what is basically VVV here in this thing? So basically in installation, when you went to the film exhibition in the bunker, you maybe have seen this screen there, which basically turns yourself into Elon Musk, and you can kind of transform it into gestures or into things you might not gonna do or you maybe don't like to do. And so basically, I don't want to go too deep in it because we, again, 15 minutes for each talk, we're running out of time. Just wanted to say, like, so here in this example for this project, we use VVV, namely this called stream diffusion. It's a model where you can, or basically it's a technique where you can use in VVV to do, for example, prompts, and then it's going to be turned into those visuals, and that's possible with VVV. And that's kind of short introduction, and therefore I think we're gonna hand over to the next project. By the way, actually, what is Elon doing right now? Is he jobless? Do you know that?
He just got offered $1 trillion by the board from Tesla.
All right, that's good deal.
He's doing good.
Thank you so much. Very much fun. If there is an immediate question, I would take it. Otherwise, we would keep it for the after everything is over, because we're gonna hang out a bit longer here when the presentations are done. Do we have an immediate urgency for a question? I take it as a no. Good. So next presentation, we have Christopher Kiermaier, aka Chick. This is a very difficult name to pronounce, but this is how he's called on the forum of VVV. You may know him from the beginners workshop, from the, how is it called now? The Big Bang is still? Yeah, the Big Bang is basically a package for beginners when they're gonna start learning VVV. And that is something that Christoph is doing, and he's also doing some tutorials once in a while. I haven't seen a tutorial for a long time now, since we have you here.
That's a bit overdue.
Could we just could we just boo him for a second? All right. Until he's getting ready for this, is that are you connected to the?
No, we don't do it. All good.
Okay, good. I should keep talking and entertain you. Is there any question for the Elon project so far? It's less urgent, but also it's okay. So the question is that what is the library? Because yes, what is the library that they were using? Yeah, that is it's a package developed by Tebian. It is called I think, if I'm not mistaken, VL.Python is the name of the library that includes stream diffusion and basically diffusion and other approaches as well. And that is something that runs in real time. I think I was looking over the shoulder of Simon when he was patching this in the bunker. Yeah, I'm out of entertainment. Either I can tell a joke or...
We can swap. I need to install Zoom.
Yeah.
Quickly.
If
somebody else wants to...
Should we switch?
Yeah.
Joanna, would you... Is Joanna here?
No, she's like at a toilet, I think. Anyway, I think we are there. Let's do it. Good.
There is VVVV sponsored beer outside for don't leave. I think we cannot bring them back. Not just yet. I think we're gonna get there in a blink.
Has the sound?
Yeah. wait, I need to share with.
That looks good.
So.
The sound setting, can you add quickly the sound settings? In Zoom, the sound settings? Oh, good. Yeah.
That works?
Yeah.
Okay.
Yeah, go ahead.
Yeah.
Well, I would say you lost 2 minutes of your time.
Oh, thank you very much. Okay. Yeah.
Okay, tell us who you are. The stage is yours.
So my name is Christoph. I'm running a studio called 3E8 based in Vienna and Berlin, and we're a studio for digital art, interactive exhibitions, and productions with creative technology. We work for curators and agencies and institutes. Also, we're a media artistic group doing AV performances, data visualizations, and political activism. And as I said, we're in Vienna and Berlin. So here's a little insight into our office in Vienna that we share with an architectural studio called MVD. And recently we joined forces with 3 touch designer artists called Marta Peng, Ars Electronica. Maybe you know these, for the Pixel Forest in Berlin. So this is going to be our office, which is going to open soon. And not to forget that we are a team. So last year, Philipp Harteder joined us as a creative technologist, working full-time at our studio. And on the right side, you see a team that we gathered in March 2024 when we started the project developing our own VL libraries for our projects. So on the left side, you see the infamous Rosi Grillmeier. Somewhere she's here. I don't know where she is. There you are. Felix Betzenbichler, Ben Wesch, Thomas Geisel, Elena Kokaleska, also in the audience here. And on the right side, that's me. What we started back then is basically we got funded by Vienna Business Agency in Vienna for developing our own set of libraries for our projects. So basically we gathered a collection of 9 libraries together that we need for our projects in the upcoming years. And also we got the funding for developing up to 4 media arts projects that use these libraries, or actually that we use to develop these libraries. So the modules are basically these 9 modules: gesture and object recognition for multi-touch screens, camera tracking for body, hands, and faces, then a module for haptic interfaces and physical computing, a module for real-time data visualization, an audio synthesis library based on the Super Collider audio environment, an installation, a library for light installations, controlling light installations, a library to control V4 applications via remote mobile web interfaces, a content management system, and finally a block about installation and maintenance workflows. So stuff like a Windows image that we can reuse from project to project or stuff like that. So when you start working on a 3E8 project, in our case, the V4 environment starts like this. So we have these set of libraries. You can see here already there's a library called VL38, VL38 DataVis, Directors, Interlinked, Lucy, Visuals. All of these are libraries that we now developed in the last 2 years to be reused in our projects. And I want to give a short overview over what these libraries are doing each independently, and then also how we maintain these libraries and what workflows are behind these libraries. So VL38 is kind of, I would say, it's the main entry point in our studio work. So it's kind of also what we think is like the entry point into sharing the knowledge between our team members for interns coming along. So it doesn't have so many nodes that we use in our projects, but it's more like a documentation centerpiece that we use in our projects. Also, for example, templates and best practices we collect here in the help browser. Then Nexus is a library that we developed to control V4 applications with up to 40, 50 mobile web interfaces, where each web interface is controlling a single part of the application. Then I'm going to demo this later. It's called VL Kit. It's a work in progress name. And also it doesn't contain 3.8 in the title because we're intending to release this library at some point. And what this library is basically doing, it's managing touches in multi-touch applications. So whenever you're developing a multi-touch application in V4, you have the problem that when you try to detect a hit of a finger in one area, you need to somehow block the layers to not let the touch propagate to the layers down there. And this is something this library is managing for us. Then DataVis, this is a special shout out to Rosi. Rosi developed these data visualizations, both 2D and 3D representations of data sets, mainly based on GIS workflows. I don't know if you know GIS, it's a term called Geoinformation Systems, where you can extract data based on textures from architectural databases and stuff like that. And we're using these data sets then to emit particles using Fuse, for example. I'm waiting for people to take photos. So, for instance, this is a patch that Rosi did at some point where we have a collection of points in the city transforming to a different data set. Yeah, so these are. This is a. Oh, the quality is not so good up there. Whatever. Then we have a library called Directors. It's I would say it's also in the realm of a project. It's extremely boring content management, but extremely important because you want to be flexible until the very end of an exhibition or a trade fair, until the customer is giving the final content and the images and stuff like that. So we've built a wrapper around Directors to manage content for our installations. Special shout out to Thomas Geisel, who helped us with this here. And then finally, a library communicating with the Super Collider server that I started out of fun 2 years ago, and we did not make it more than until a proof of concept where we're really just controlling very simple oscillators from V4. Yeah, I think that's enough. But for this video, I'm getting 2 minutes back now. So these were the libraries that we wrapped. We see our studio as a system, so we are constantly fine-tuning the workflows, the parameters of our work. Where every project, we're trying to step away back and see, okay, which of these modules can we reuse? How can we wrap them into something that we can then further develop in the next project? And also then use these projects in our own artworks. So this is something that is very important and dear to us, that we're not losing the connection to digital art and not only doing commercial works. So after 2 years of R&D, we've come to a point where we have these internal development libraries that we deliberately maintain as a knowledge base for our crew and for interns. We're deploying them to our own Nugget server on GitHub, so we're not using nugget.org as a public server to download them, but we are deploying them only if you have added a private key to GitHub. And also, what is very important, I will show you, we're versioning our own libraries. So we're not loading them from source as a package repositories. People from the V4 world will know this term, but we are really building our library into a version, so we can then later control which version works best for a specific project. So I would like, how many minutes do I have left?
Yeah, generous 5 more minutes.
5?
5.
Okay, then I just want to make a very quick live demo. So normally in V4, when you install a Nugget, you go to the quad menu up here. You go to Manage Nugget, okay, there's a lot of stuff red, but Manage Nuggets, command line. And you usually start with a command called NuGet install and then VL. And in our case, I want to install now the 3.8 library, and I'm in the network, that's right, yeah. But usually you hit enter now, but what we add in our case is now source 3.8, and this is something I've done before. So I've added like this Nugget server or a GitHub server, I added to my environment. And once I hit enter, if everything works fine, the Nugget is being installed and appearing in the node browser. So if I type in VL38, you see that it's now being loaded in here. And another nugget I want to install quickly to show you. Nugget install VL kit minus source 3.8. Is it still thinking? Okay. So this I want to install, and then 3.8 directives. Yeah, and like with every other V4 library, when you install the library, you get some help patches in the help browser. So if I go now to the Learn section, I see all the help patches that I've told you about. So these are starting point templates, workflows for people from our team. And then, for instance, if I now click on Kit, so I have this help patch called Kit Overview, and I hope it works now. So this is the library really just serving the purpose of managing touches in complex applications. So each of these three shapes in here, they are interactive areas that you can click, and also they're possible to be controlled with up to 100 touches. But this quad in particular is affecting the states, so things are not rotating afterwards after I click them. But what you can see now is that these two layers, they are clickable independently. So whenever I click this, it's not propagating the touch down to the layer beneath. Yeah, and this is a mechanism that I was very inspired back then by this library from MicroD in beta times, not UIV, it was called, where he basically defined invisible layers up there that can react to touches and can react to gestures and stuff like that. But in the way they are piped into something else, in this case I called this now the node kit. This kit node is basically managing all the touches in all of these layers and then just letting pass whatever is not, is weird to pronounce, but yeah, letting pass whatever is not blocked at this specific point. So I hope this was not too abstract, but it's really a problem that you run into when you're developing multi-touch applications, because we're so much used to how all of this stuff works these days in our smartphones. And another thing is this directives library. So I just want to quickly show this one here. So this is kind of managing the assets in a project that we're currently developing. So we have this directives instance in, the Zoom window is blocking everything. We have this directives instance in the web. So here we are basically managing data, managing images, managing videos, user interface text and stuff like that. And in our application, I have this media manager node. Once I refresh that, we see that we get all the ideas of the media used in this application. And I can then, this won't work right now because it's in a help patch. I think there won't be access to the folder of this help patch, but I can now, depending on the application, I can trigger this button. It will download all the assets, cache them on the library, and that's it. Yeah. I wanted to quickly go over projects that we developed based on these things. I will just jump over the slides very quickly. It will take 1 minute. Yeah?
1 minute is good.
Okay. So as I said, we got funded also for developing 4 own installations using these libraries. And I just want to quickly show them so you get an overview. One installation we did for Klimabiennale in Vienna in Volkskundemuseum in May 24, where we visualize emotions from climate activists towards specific locations in Vienna. I won't show the video now. We have a video, by the way. One light installation that we customly built, we welded everything, we soldered everything, we printed everything. It was a hell of a work. Every time you're doing a light installation, calculate 4 times as much time you estimate in the beginning. Then another sound installation we did based on a structure provided by Autosonics and Tangible Music Lab, where we also visualize spatialized sound in 2 ambisonic structures. Sorry. And the last thing we're working on at the moment is an exhibition in Pinakothek in Munich called City in the Cloud Data on the Ground. dealing with structural problems of city planning due to digitalization and smart cities infrastructures, and very complex. We're doing this at the moment. If you want to stay in touch, please do so. Here are the contact emails. And also I would like to quickly mention, I'm offering every semester this beginner's course for V4. We are currently in the registration phase, so we're starting end of October. And if you want to join, please hit me up afterwards. I will happily give you a discount code. Thank you very much.
Thank you very much, Chris. Could we have you here for a second? You mentioned a few things for those people who don't know. What is a NuGet? Like, what do you mean by NuGet when you were talking that? Oh, you were doing a lot of nerdy stuff there, and I would like to know. Could you just show us, for example, the NuGet gallery if you still have your screen there, and if there is any question for Chris, like one question we can take.
So
please. Is it scriptable? What is scriptable?
What do you mean scriptable?
So could you create a script to create the nodes for your custom libraries?
The question is if you can script your own nodes for your custom libraries. Is that correct?
Yeah.
Yeah.
Can you create a script which would create the nodes?
Can you create a script that creates a node?
This is not how it works in V4. You can patch your nodes. You can patch the definitions of your nodes to your libraries. But what I forgot, I notice right now, I forgot to show the CI/CD pipeline. So every library that we want to deploy, we can bundle this and publish this to our own NuGet server. And this is now, I don't know if you mean this by scriptable. So basically, we can script like the bundling process of putting together a library that we can then later reuse and install from our own library server. Is this what you mean? Like the CI/CD pipeline? Yeah. I don't write
So maybe because those people who only hear through this microphone, sorry, I had to come over and hand in a microphone for the next one. I will do that. The question was if you can just write a script and this script would become automatically a node. The short answer is yes. The long answer is also yes. So it's basically possible to do that in. Well, depends. Well. That's the thing about V4. One thing about the NuGet that you mentioned, generally, very sorry, I need to do it myself be very quick to have the next one. So the NuGet is basically a package management for .NET. And the good thing about VL is that you could create and consume those packages that are on the NuGet on the NuGet gallery. Basically, this is what Chris was doing. So this is basically the NuGet gallery. You can write things with the VL prefix, and whatever VL dot you say is ready to be used in VL. There are also a lot of packages that are not ready to be used there, but you can basically, if you know how the package has been structured, you can wrap it yourself and you can share it with the others. That's a good thing. So, thank you very much, Chris. We will have Chris as well for afterwards. If you have questions, you can ask him. I would like to ask Simon to introduce our next presentator. Thank you.
Thank you very much.
Test? No? Test. All right. So for our next speaker, we have Joanna, and we are very honored to have here in our VV meetup because she is basically one of the winners of the honorary mention as well as the award of distinction, as I remember. And today she will talk about her project Fluid Anatomy, which is being shown in the film exhibition as well. And I'm looking forward to see what it is.
Hello? Oh, it's good. Yes, so we will delve a little bit in the world of hardware, actually of physical computing. Some of you might already know my work or bits of this presentation of I will basically show you a little bit of the research behind the project that is at Post City. So I started working, most of my work is about computing and the history of hardware, as well as memory. And at some point I discovered this image. Actually, on the left, you can see this is a classic microchip. It's a CMOS circuit. This is how we build our computers today. And on the right, there is something much different. It is a fluidic chip. It has the same function like the device on the left, but it actually uses a very different materiality. It uses air and water to perform logic functions. So when I discovered firstly these shapes, I was really intrigued because I was like, what the hell are these things? And I could not find any documentation about them. It's almost like a chapter that has been erased from computer science. And I was intrigued, like why and how it happened. So I started to delve in the archives of the Technical University in Berlin, and I discovered this whole very interesting technology. It seems that at the same time that the Bell Labs was inventing the transistor, there was at the Diamond Labs another kind of transistor called the fluidistor, which instead of using electricity, it would use water and air. It looks like this. This is a recreated fluidistor that I made. And this is not something new, actually. It has a very long tradition. It comes from the earliest of times, in the ancient times. Some of the first computers were actually built with water. So this is a Persian clock, and I call it a computer. Now, of course, the definition can be stretched in many ways. But basically, it would say the time by sinking. So you have a big vessel with water, you put a ball with a hole, and it sinks. And the more it sinks, the more you can see this gradation and say, well, this was a minute, this was an hour, and so on. So this tradition is actually nothing new. In ancient China as well, we have the Susong's astronomical clock, where the movement of water would run a big wheel, and this big wheel would map the living of the sky. So people had a lot of questions. How does the universe work, and how does time work? And for this, we build machines. Another beautiful example is Al-Jazari's Ingenious Mechanical Devices. This is a book that I highly recommend if you're interested in pneumatic, hydraulics, or all sorts of this field. So he invents a few of more complex clocks based on the same idea, sinking, quantity of fluid, fluid flow. On the left, we have a clock, so like a timer, and on the right we have a perpetual flute, which we will see later is almost the same with a fluidic oscillator. It creates a periodic movement. And much later, a machine that I still find very intriguing, and I try to push it forward every time, Moniac. Moniac appears, and this is a computer that would tell the workings of a complex economy through the quantities of water. It's invented by Bill Phillips, and he finds a way to recreate the entire ecosystem of Great Britain's economy. We will watch this video.
These two parts over here, which is where money can actually come into the economy. The actual water flowing around is the money going through the economy.
That enabled you to illustrate, for instance, what would happen if you try to grow the economy, pump more money into the economy. For instance, you could increase government expenditure and see what the effect of that is through the workings of the economy, the interaction of all the variables on growth. Of course, if the economy is very prone to imports, people might simply spend their money to import foreign goods. Or if the economy is operating at a high level of activity, then that would lead to inflation.
So inflation indeed it is. And as we can see, like at the same time with Bill Phillips, it's 1950s, these circuits start to appear from different parts of the world. They are very small and they're very large at the same time. And they look very organic. And I was very intrigued to see how they function. And I discovered that actually they function based on a principle that comes from the Romanian physicist Henry Coandă. It's called the Coandă effect. We will actually look a little bit of how this effect works.
VVVV
So you can attach jets of streams of liquid or air by creating different forms. It's the same like this. You deviate a stream with your finger. And this video comes actually from the USSR because they use this technology a lot in Eastern Europe. And I ended up finding a lot of archives from these places. So it's also like when you pour water from a glass and the water sticks to the glass. This is because of the Quandt effect. So now what if we build forms that use this effect to do various things? And in the end, what was fluidics actually used for? Well, it was mostly used at different applications, such as in aviatics. NASA used it, for instance. This is a circuit that was proposed for space exploration. I also included in my installation one of these circuits. It was also used for all kinds of automation, so let's say pneumatic arms and so on. But some of the more interesting uses are Tadeusz Dzieciewicz, telecom, so a radio that used compressed air, and then computing. So I was intrigued by the computing part because I'm looking a lot in the history of the computers, and I was also intrigued to understand why we don't know about this, why nobody knows about this field, where it seems that it failed commercially because it was too slow. It was a technology that abided the natural physics of the fluid flow, and it could not compete with electronics. It could not run on the market. And I thought that was quite poetic. So I started to de-archive it, which is what I call taking these old shapes and putting them back into use. So this is in 2020, 21 or 22, I was at the Tangible Music Lab right across there, and I started to prototype these units, these modules. They came across like that. I was indexing these shapes. I made them quite small, and the idea was to create a modular system that I could teach people how logic conditions worked. These are the shapes that came out of that. These are extracted from the patents, reinterpreted, and put back into function. So I create this language. It's kind of like a sign language of these logic conditions. And now we will dive very quickly into how they work. So let's look at an oscillator, for instance. This is a fluidic transistor on the left that I was showing. It would always go on the right or on the left side because of the Quandt effect. The Quandt effect makes the water stick into one leg or the other. But what happens if we feed back the input with the output and we create this shape? Well, it starts to oscillate. So here you can see how it oscillates. That's a very similar shape. It's a different shape, but it's also an oscillator. You can see the fluid starts to move back and forth. And when this is done with air, we obtain sound. I don't know if we can. Very low. A very small whistle. So these are the sounds that you will hear from the installation. They're all oscillations of fluid. And when this is done with water, in this case, the feedback paths are very long, so the oscillation is very slow. And now we can see it pulsing. So it's oscillating that slow. I think the internet is also kind of slow, so we don't see it very well. But maybe now that there is a zoom in, you will see. It starts to really move the liquid up from left to right. Now it's coming left, right. Oh yeah, it's very slow rate. But we almost see it like that. And then there's the logic part, right? Because computing is not about oscillating and creating nice sounds, but you need a certain kind of building blocks. And here's where I followed these Bowles charts, and I tried to recreate these shapes. So they were using these systems, and they actually did create a few Turing machine complete computers with them. Usually they would look like this. This is on the left, you have an X-ray scan of a full adder. On the left, on the right, you can see how it would look from outside, so all the vents could be plugged. Of course, they were never visible because they didn't care how they look. And also when they started to construct, there was a lot of theories that used the body anatomy as a kind of analogy to these shapes. So one of the logic elements called the equivalence is built after the human throat. And here we can see the comparison of a scientist who tries to build an entire fluidic system after the human body. This is the logic element called equivalence. You can also hear it in the installation in the bunker. It is forming an oscillation and a very throaty sound. Yeah, it's modeling this thing. So then we have things such as AND gates, where two jets collide, and only when they will collide from those sides, it will go on the third output. So a different kind of effect, like interaction jet. We have OR and NOR gates, for instance, where based on the same quanta effect, a jet will deflect on that path only when the control is positive. We will have a signal on this leg. And when I talk about signal, I talk about water or no water, just to be understood, or air or no air. Yeah, I'm almost there. We have adders, and then we can create circuits. And they did create all these complex circuits with these elements, and I set myself to do the same. So I took these elements, different various forms, I de-archived them, and I turned them into plates. This is what you will see down in the bunker. And then the programming and the patching, the circuit, was done with these tubes. So I create these large circuits, which compute themselves. It's a very stupid computer. There's a memory array. There's these large oscillators that trigger the system, and the whole organism kind of sets itself back into balance perpetually. So it doesn't have a clear function, because that I was more interested into showing the shapes as they are. Thank you.
Well, thank you very much, Joanna. Are there any questions? There we go.
Yes, there is not. I have not found the physical computer. I would love to. It's almost impossible to find anyone that knows anything about this field. I do have a physicist that I work with regularly, but I do have modules, components, which one of them is presenting in the research box, some of the original that were being sold commercially for a very short time. Then it kind of got out of the use. But the full computer is called the FlowDuck. And if you find anything about it, I'm very happy, because I could not find more than one paper about it. Yeah. Yeah.
Yeah, there we go.
I have a question. Is a drop a bit a 1 and the air a 0?
I mean, it can be what you want, you know. It's theoretically, and this is the beauty of the analogous computers, of the analog computers, it's an analogy. You can say, yes, it is when there is water, it's a positive. When there is no water, it is negative. Of course, when you have air, you say air, jet of air, 1, no jet of air, 0. But these systems are between digital and analog. I wouldn't call them digital because they're not digital. They actually work proportionally as well. So there's a lot of like proportional elements, like the same fluidic amplifier. You can use it as a switch to switch jets from left to right, but you can also use it to deflect proportionally, which means that you can build analog computers. And I think that this is much more suited for analog computing rather than digital computing. Although it can be a very beautiful way to show how digital computing works, like, if it makes sense. This is always like...
Well, Joanna, again, thank you very much. Amazing talk, amazing project. And I guess, I don't know, fluid computing, maybe also something interesting for the V4 community. Who knows if this is the future. Next we have Nathan, the godfather of particles. But this time he is going to present us a new material he's working on since a while. I hope you joined the performance at Deep Space today, and he will show us how he made his performance forms of resonance together with Augustine. And yeah, let's get started.
Cool. Do you hear me?
Yep.
Does it work? Okay. So yeah, I don't know how many of you saw the performance. Yeah, let me just. Where is it? Should be okay. Share.
Just click share sound
as well.
Yes, and then you want to share the screen, right?
Yeah.
And share.
Cool.
Yeah, this one, yeah. I think we have to optimize a bit. That's fine.
Ooh, that's quite slow. Somehow it's slow.
That's fine. Which internet you are using?
The external network. Okay. Anyway, I wanted to show a little video for those that didn't see the performance, but I don't know if we will see anything. Oh, okay, very slow. Anyway, it's audiovisual performance where there's a piano, classical music, and there is me on that side with a table full of stuff. Yeah, we mainly let's watch it a bit. So I can give you some insight about how we did it. As you see, on top of the piano, there is this arm with a sensor. So originally, actually, what we performed today was like a reduced version of the show, which is 1 hour. This was like 25 minutes. And originally, I prepared this show using a MIDI piano. So I had the MIDI from the piano, that was sending me all the notes. So I used that. So this time I used the sound analysis to get some information of the playing, but also I really, this is something interesting. I really wanted to capture the hands motion of the pianist. And that's why I use this sensor on top, which is a lip motion sensor. It tracks your hand, okay? Gives you the skeleton information in real time, very accurate. And I really wanted to do that because music is so much into the movement. So when you watch a performer, a pianist, the music is already in the gesture even before it touches the key. Okay, there's so much in the air while you play. I'm also a musician, so I feel so much that. In fact, most of the show actually, I mostly use this sensor because it was so interesting to get this information of what you don't hear, what you don't hear, what is not in the music, but clearly reflects and embody the spirit of the music, no? In this motion, in the body that plays. And I use the same sensor for myself there on my desk because I also want to I'm Italian, so I need to move my hands. No, but I'm a dancer too, so this was a good opportunity to explore the physicality of music as well. So this was the setup. Piano with a microphone or MIDI, these two sensors. Then I had some controllers and also a foot controller As you see, the program was classical music from different periods. Yes, so I used V4 to create all this stuff, and this for me is like is not a complete artwork. It's more like a work in progress. Also because I started to use to explore different kinds of way to draw things. Okay. We're used to use a lot of geometry and also particles. I really wanted to go beyond this way of thinking of shapes and visual elements. I was really looking into a way of dealing with matter, with the physicality of something. That a body is something that is way beyond its surface. No, so I really wanted to explore how I could, get a sense of that and work with that perspective in mind. And that's why I started developing like a little library in V4, which allows me to describe things volumetrically instead of saying, okay, this is a bunch of points, connect them with faces, and that's your sphere. No, in my case scenario, I want to have in this part of the space is full with this substance which has a certain density and a certain color, and that's why that's a sphere that somehow blocks the light or scatter through. So I developed this library that maybe can also show briefly a patch. I don't know if it works. Yeah. So a little scene here, just to show you that this is a simple description where I have three objects with a plane, and I'm defining, okay, this is my box. I place it somewhere, and then if I go to, then this also is like a system to create the performance. It's like a parametric system that they created to create performances. But what I wanted to show is that when I move the light, if it moves, it doesn't move. Okay, it's probably. Let me check. It doesn't want to move. Okay, well, I just did it before. Didn't even check. Let's try to restart. In the meantime, I can start playing some music. Are we even here? Okay. Sorry, I'm getting there. I'm also very tired. So we just finished. Yeah, okay. As you see, when I move the light, there's really like light scattered through the object and casts a shadow which captures the color of the object, because it's really goes through the object and get influenced by the physicality of the object. So if I move it a bit down and towards the ball there, you will see that the ball is a bit denser, in the sense if I go inside with the light, I have this sort of effect where this ball lights up with this light because of the color. So it's like a volumetric rendering engine, okay, which I developed in V4 as a node set. And so for me, this was a first step into exploring a bit how I could render this stuff. Because obviously you cannot rely on geometry, you need to use other techniques to render things, which is called ray marching. It's way more expensive and different problematics. But the cool thing is that I managed to create this library as node set, also thanks to the fact that together with some friends we developed a library which is called Fuse that allows us to basically patch shaders, all sorts of shaders, compute shading, and that's how we build also particle system nowadays. We can simply create modules and we can patch all these shaders in runtime. So this lighting edging somehow is the core of like of the live show in terms of visuals. That I'm also mixing with some classic particle systems and geometries, but yeah, I can also show maybe the hands. So the lip motion was sending me the information of the hands, and I was using those to emit density in a volume, a fluid simulation. And then I was rendering, visualizing this fluid simulation in this volumetric way. And yeah, it's a new journey for me. There are a lot of pros and a lot of cons, but I think it's really cool that you can think differently. What you want to, what you draw and what you show. So there are obviously I'm interested in combining both things, like a standard way to draw things, like particles. How can I integrate them into this volumetric way to render things? So I spent most of the time developing the technology, and like I did the show like in 2.5 weeks. Unfortunately, so this is really like a starting point for me. Also, I'm gonna work a bit more on the designs and exploring the features. It's cool though, because once you define the technique, a certain kind of technique, you define a perspective, then you start realizing also during the workflow that creatively new things arise. Like for example, this scene here, it's so simple, the one that I showed you before. It's probably the first thing that I tried, and then I kept it because it's cool that the hands are emitting these volumes, okay? And then I enable this point light there, no, to show the volume. And for some reason, that point light was exactly in a position where the wrist of the pianist passed through when he jumps and when he plays different spectrum of the melodies, right? So suddenly this somehow this light pulses enriched the music somehow, giving a sense of the structure of the music itself, because it's like pointing out a moment that you maybe don't notice, but it simply arises out of this pulsation, and you recognize it in the music as well. So it's cool that once you define somehow the settings, the limits, and you play within those, then you can really discover things about music and how you want to perceive the material. And yeah, 3 minutes, 2 minutes. I mean, I don't know if there are questions as well. I'm up for answering. I know that there's not much time. So
short comment. But anyway, I hope you can hear me. No, thank you. It's beautiful. You have beautiful imagery and the concept. But I think your work and some other work, they have some kind of share this probably common problem with, especially when acoustic live instruments, for example, in deep space, that there's this usually for some more or less this delay. You know, the delay of, for example, hitting the note or kind of making a gesture. That's probably depends very much of the complexity of this rendering kind of effects and other things that you use, and maybe sometimes there's additional latency through going through different cables and I don't know what kind of converters, projector and everything. It kind of adds up, and probably there could be different ways of dealing with that, either recording and shifting the time sync, or putting the poor performer some other room he doesn't, you know, we don't hear him, and we get his signal with a delay, and but yeah, how it was your case, how you balanced that?
It's almost 20 years that I'm doing this kind of work, like visuals with musicians, orchestras, and if your setup is done correctly, it's not an issue, because like usually you try to render at 60 frames per second. In the audio domain, that's nothing, you know, it's a huge amount of time, right? So to run a sound analysis, for example, it's completely fine. So if you want, you can get very hot spot on point visuals. Actually, in huge venues, I had to add delay to my visuals because the people in the back were seeing the images before the sound. So you need to calibrate that, no? So, and also, the one aspect is many times you're not even interested in having like the perfect synchronization. Sometimes it's more important, more interesting to have a decoupling of the visuals, because that's what happens also inside you when you listen to music. It's like someone give you an impulse, but the reaction has its own time to develop, right? So I think that usually it's interesting to work with different layers of reactiveness, you know, and so that you can create like a more organic and rich perception of what happens and the consequences, like all the echoes of that note, no? Then maybe the pianist hit that note, and then after a while you see something, and you feel that in that void that separates the two moments, there is the depth and the richness of what moved. Okay, so it's interesting to play with time and the voids that you artificially or by necessity you create. Yeah.
Maybe we could take one more question. Unfortunately, we need to move forward. It's just I don't know. Is it the trick that you do that you put also this beautiful music in the background with these nice visuals? So like everybody's like, oh, let's go on. But we have to wrap up at some point and hand the room back. So I would like to take one more question if there is one. Anyone? Sorry, Motsi, you are the privileged. You have access to people to Nathan and the others. So I would like to know if anybody else has a question. Sorry.
It's not really a question. It's just, can you tell your name and where we can follow your work, please? Thank you.
My name is Nathan Sinigaglia, and you can find on the program also the information. We performed like 2 hours ago this piece in deep space here. It's Forms of Resonance is the name of the project, and there you can find the links.
That was a very quick one. So I could take one more. Strangers, you look strange enough.
Thank you very much. And this is also more like a community question.
Are you thinking about actually making this your library like open to like for everybody to use? You know, because it would be very nice for sure.
Yeah, I'm used to public libraries, so this one, as I said, is a work in progress, and I just didn't develop only this one. This project combines so many other packages, so I will need to find some time to polish things. And but indeed, that's my interest also. Usually I publish my research, so yeah, at some point. Yes.
Amazing. So next one, the next one is Noor. While you're setting it up, we can ask one more. Thank you so much, Nathan. Amazing. While Noor is setting up, I think it might take one or two more minutes. Nathan. Nathan, how many libraries have you developed for the things that you're doing? Like I know Elementa, early days of, I don't know, Kairos from years ago that is still under development.
This heavily used Kairos.
This heavily used Kairos.
Which is an animation framework that I'm using to control this system. So where I can even timeline shaders generation.
For those who don't know, what Kairos is also another package that is developed by Nathan. You can also go, if you remember how Chris was showing you the Nugget gallery, you can just use vl.kairos and then see. It's basically a timeline, but more than a timeline. As Nathan once said, this is a time manager. So
controller.
Time controller. You can also travel in time if you want to, back and forth.
System controller.
Thank you so much, Nathan.
It's a pleasure.
Hello. Well, that's a pleasure after Nathan. My name is Noor, and I'm presenting the project that you could also see at the moment in a team exhibition in the bunker, Microgravity. It's a project I worked on together with Amir Bastan, but since he's your host, I have the pleasure to stand here in front of you. And Johannes Brauman from the Creative Robotics Lab. We all are connected to the Creative Robotics Lab. And excuse my video, I made that just now. I just finished this presentation for you because the project exists since a few days. Microgravity is a robotic installation where we explore how or if it is even possible to grow pink oyster mushrooms in altered gravity. So what you see is on top of the robotic arm is a bioreactor, and in the middle this cube is a cube filled with mycelium. Mycelium is what you could see as the root system of mushrooms, and on the outside you see pink oyster mushrooms starting to grow, which answers already the first question. Yes, you can grow mushrooms in altered gravity, which is nice, but also already answered luckily before by space research, so we had a guess that would work out. We create altered gravity through constant motion. So basically, if you see this shape around it, you could imagine the shape once more around it, and it doesn't rotate, but it does of course move with the robot. And what we do is we show one side of the box to one of the vertices, we rotate around it, and then we rotate to a next vertex. And through this path of continuous motion, you basically simply said confuse the center enough that they don't know what is up or down, and lower the gravity, as if the gravity comes actually from the outside. So on one hand, we look at what that does with the fruiting bodies, because all organisms are shaped on this planet by, of course, gravity. And on the other hand, we collect a lot of data because what we know is that the mycelium exchanges very small signals, and we are trying to figure out if we can get a better sense of what these signals are. So in the box, there are very thin needles, subdermal needles, which they use in brain surgery to pick up these microvoltages. And afterwards, we have the time to then look at all the data that we collect. We have the visualization, of course, of the robotic movement. We have an IMU sensor in there. We know the CO2, we know the temperature, we know the humidity, and we know those signals to see if, except for their physical changes, also there's any thing we can sense within the mycelium itself. Yeah, I absolutely did not time how long this was going to be, so I made a really long video. But maybe to continue to what the main elements are, as we are also, of course, a bit more interested in maybe the backside of this, is we have a local server what basically where everything connects to. So all these, you have the mycelium, all the sensors, and all the sensors bring it to the local server. One of the sensors is a Pico data logger. That is a very high definition analog to digital, and that we basically. I'm also very tired, like Nathan. That is what we basically all send to the computer, and where we also get everything from the robot. And where it all is being calculated. The very nice thing what we have for this is that, of course, during the exhibition a lot of people are around our installation, and normally a robotic arm like this, an industrial robot, should be in a cage, but we don't want it in a cage because we want you to also see it. So we have a laser system to protect the area around it, but therefore we also want to know, of course, always is the robot running and can we already see some of the data. So we have a very nice Telegram bot with our robot, which I think is my most ongoing conversation these days. The only one I always answer. And what you see is that we can ask for an update, but also it will send us our least favorite message, what you see on top, called stopped. Because the moment it stops, of course, it ruins also our research, because then it is clearly in our gravity. So it is very essential for us to keep the installation running 24/7 during the festival. We're planning to, at a certain point, maybe clean this more up, that we can also live stream this, but yeah, we didn't manage, basically, as we had a lot of other things to tackle before the festival opened. But here you see basically everything that we collect. So you see the acceleration, you see the 3 channels of the mycelium signals, you see the CO2, you see the gyroscopy, you see humidity, you see also if the humidifier, which we now call humidity, is on or not on, because this bioreactor is basically creating the perfect situation for those mushrooms except for gravity. And the temperature and in which position all axes of the robot are. So afterwards we can really basically recreate the whole work again to further research it. That also came in the process with a lot of testing on how are we going. This is Amir being a robot. I thought that is something you probably don't want to miss. On how can we make something that is strong enough, but also a very big question that it needs to be light enough. Because although we have a very big robot that is 500 kilograms, it can just carry 30 kilograms. So we had to be very precise with all the materials that we used. We had even you see there. Next to my feet, some bags and boxes, because I also had to find exactly the right substrate that was good for the mushrooms to grow, but also light enough, so it could not be wood, because wood is very heavy. So that has been a very big part of the process, like how can we also make a bioreactor that fits the situation. And then we built it up for the first time here. Now in the festival, we could be there a little bit longer, which brought some new problems, like this LiDAR system that protects our robot has been the biggest headache I could ever imagine. Because basically, the moment the LiDAR detects something, it stops the robot and it cannot move. Here, the robot stopped itself, and it couldn't move anymore. It was quite a big problem, because how do you move something that is completely protected? And we have had a lot of ghosts coming in, of course, from other sides, from laser beamers that were coming into our laser. We know now that the ice from hazer stays on people's clothes, and the moment they come down into our room, these tiny particles fall down and stop the robot. So it was quite a hunt to keep it running 24/7, but now on day 4, we're there, kind of, unless people walk in. And then the big question that we always get, do we already see a little bit if they are different? Well, here you see normal pink oyster mushrooms on the Hauptplatz. As you see, they grow quite open, quite big, and they have very tiny gills on the down part, which they always want to have downwards to spread their spores. And here on the side, you see how they are slowly growing. And just before this meeting, I had a meeting with my mushroom community, which is an equally nerdy community, but then on a different topic. And what we see is that the mushrooms develop very differently when they are in this altered gravity. They basically they put every part inside, outside, and backwards, and upwards, and downwards, and they don't know where to do it. Which I think brings very interesting shapes, and also is maybe a good thing to think about, like that, how much maybe we're bound to forces here, and how unexpected and delicately we could change if we bring ourselves in different places, and what that brings as questions and challenges. So yeah. I think I'm then on my 10 minutes. I would say see you tomorrow in the bunker. If you haven't been there, then you can see them grow yourself. This was yesterday. Tomorrow they might be like that. That was our test box. And yeah, if there are any questions, I'm happy to answer them. And maybe, Amir, you should also be here for questions to answer them with me.
I take questions. I think you basically mentioned anything. So
okay,
yeah.
Lovely.
Any questions? There's one question. Yeah.
Hi, I saw the project. It's really nice. Congratulations on the cool results. I'm wondering about the color, because on the left it's like pretty yellow, and on the right more pinkish.
That's their age. Just like us, they got a little lighter when they get a little older.
Perfect. Thank you.
How does speed influences the results? Do you know, like you move the robot in a specific speed, and is it different than if you move it slower than if you go faster?
Well, the speed is not really. Amir, correct me if I'm wrong. I see you on the point. Do you want to answer it? No, I want to pass on the okay. So now, what is important is that the speed is continuously, so that there is no acceleration or no hard stops. But the speed itself, as long as that is continuous, that is fine. So you will also see that the installation is quite slow. The most people expect that you need something really fast to do this, but that is in this case not how we change the gravity. If you have a nice train, then that goes go continuously. Then yeah.
Any more question? Cool. Thank you very much, Noor.
Thank you.
Yes.
We have Noor for a few more minutes there until we set up. Simon, would you please introduce our next presenter?
Yeah, Jean Lee. I hope he's here. Right, there we go. Talking about bugs, as we hear, right, like this installation had a couple of issues with haze or with dried ice. And I remember like Jean was basically working until the last minute before the opening of Ars Electronica, like 8 hours or 6 hours before the opening, it was not running. And then kind of fixing the artwork. And what was the issue? Of course, the broken USB cable. So, but it took quite a long time actually to figure out. And we are also very honored to. Are you working on it? No pause. I see. Again, cable. To have Jean Lee here, so he will present his artwork, which is called Liminal Ring. It's a haze installation, I would say. He also won a prize for that, as I remember, Korean art prize as well. And what else should I say? I guess basically he's traveling around with this now since a while. I guess next is Korea and Romania, where if you didn't have the chance, definitely see it. I think, but you probably also saw it on Instagram because like a very it's an artwork that got quite often featured. And also, I guess we also invited Jean for this artwork because of the material, like what Nathan presented, and now we're gonna kind of get the physical or the analog version of it, so to say. But are we ready to go? Yeah? No? Okay, no. That's gonna be the last speaker for today, and then maybe we have a special one, who knows? Maybe if we have a bit of time, we might also gonna have like one extra speaker, let's see. But yeah, next 50 minutes is for Jean.
So it does seem like that we will be very much on time. Is there anybody here who would like to just bring the laptop up and show something?
I mean, for me, there's one person I would like to interview a bit because I see that Gerfried is here in the audience. And so I know, I mean, there's a long history, right, between VVV and Ars Electronica. And I do wonder if you could maybe share a couple of thoughts about VVV and how it got involved into this festival. And I know that you're also like a heavy VVV user. Unfortunately, I think, or maybe like the performance you did yesterday and also today was in Gamma, right? But you're also using Beta. So what is like your feeling? You taught me about like you're coming much more from background perspective, and like basically how do you work with this? And maybe also, do you like the new version Gamma? How is it for you?
I have to admit, I'm really a Beta junkie. It's very hard for me to move on to Gamma. I mean, of course, there are so many advantages. You have to do it. I told you I was almost on the brink to switch over to Touch Designer, but no worries, I stay with V4. It's, what I liked very much from the very beginning, also being from my background more a hardware person and music person, was especially with Beta that it hadn't to do anything with coding. It was much more the logic of hardware. You connect things, you have this flow, you don't worry about many other things. So it's for me much faster to do things. And I mean, the relationships, I think, go back very, very long time. I think it was 2003 when we did a very extensive music visualization in Bruckner House, this Rheingold Opera. This is where the Future Lab was using VVV, and since then it is, of course, many of our artists. I mean, this is what you see this year. There are really a lot of things going on. And of course, one of the great things was always the community, the way how people helped each other, how superheroes like Nathan made stuff available that helped others. And while you were starting already, there was another V4-based music performance in the deep space. And I think this really shows how spread out this whole thing. And yeah, great. Keep on going.
Yeah, I mean, also a lot of people maybe don't know that, like VV, like Jorik is also here in the crowd, like, you know, one of the founders, he's from Linz, moved to Berlin, so there's also a strong connection to VV and the city of Linz as well, right? And as you mentioned, Future Lab as well, Boy, who was one of the users, worked for Ars Electronica as well, and I guess you also push it a bit. Yeah.
Of these things going on, and I mean, I'm very happy. Thank you to, I think it was mainly Simon and Amir who brought up the idea to host this meetup here at Ars Electronica. I'm very happy, and I would be also happy if we can continue this and maybe even increase the presence of the V4 community at future festivals. I mean, we do have this very nice deep space thing, and Amir told me that with the new Gamma, it's also possible to go stereoscopic. Is this right? Okay, I mean, this is then really a super thing. Wow. So you see, I have a lot to catch up with. to really be able maybe to use it also myself. But I think this infrastructure is really a wonderful thing. As you might know, also the Art University over the bridge has their own deep space, and there's a lot of development. I mean, we have the art students developing in the university, and then they are showcasing here at the festival. So I think there's really a lot of potential to grow new stuff here between V4 and Ars Electronica. But I think the cable is now working.
Thank you very much.
And I stopped talking. Thank you very much.
Should I? Oh, okay, sorry. Hi guys, my name is Jenny. I'm based in Berlin, and usually I make kind of some kinetic artwork. Yeah, so my time, so this one is not like really crazy, high-tech project at all, and then like, this, my presentation will be like more like really nothing like really kind of some technology thing, but more like, some one guy's challenging and failed and blood and, tears and everything. So I just want to share how I can actually challenge to this project since 2 years ago, quickly. Yeah, so this is liminaling actually. So you might be already checking the bunker, and so it's very simply to explain. Then like I just want to make some artificial airflow, which is actually against the nature's turbulent flow in the air actually. Yeah, so sorry. Yeah, so there's a lot of kind of some text usually artists should put on it, as the concept, but I really want to go simply way actually. So the reason actually I choose this like, the property of the turbulent flow is because that for me is like turbulent flow is like really metaphor and super prime example of the natural complex system, because like even like we human like kind of like since the last couple of hundreds of years, and we spend a lot of kinds of money and everything, but like we can't even like really perfectly predict kind of some weather of the tomorrow actually. This is the point of the natural complex system. And yeah, and then and then the laminar flow actually is basically like just simply to say done some fluid process which has a direction actually. And then you can also find this laminar flow in nature statement, but like it's super rare, and most of kind of some whatever laminar flow by the air or the water thing is basically some devices by the human for our purpose. Yeah. So the goal of this project for me was like I really wanted to involve some parts, really small part of nature by using some technology and some devices and everything whatever I could do, and then like just try transform that small part of nature to some kind of our part. Yeah, so our means like human. So like we always like really want to control the some nature thing. I always think that why we really human doesn't really just enjoy this nature, but always ruin everything. Like we just drawing some line. Is I think we really hate to be on some situation about some which is like unpredictable actually. I really want to just share a really short story actually. Really short story. So I was in army. I'm from South Korea, and then like I'm kind of some 20 or something. And then usually we have to hold the base in the midnight, 2 or 3 hours. And then like the army base means like it's totally dark, middle of kind of some forest or something. There is no light actually. And then like you have to guard for them kind of some from here to here, 2 hours, midnight, no light, and you're just watching it. And then actually kind of the senior guy actually just for my first kind of this guard duty, then like he explained that like you never ever just point on, watching some one point actually, you always have to continuously change your point actually. So I was like, why? Then I don't know, I actually learned this shit actually, you have to do that. And after that, like, when I finished this thing, then, and as a couple of years later, actually, I met some psychophysics guy, then like, he actually explained that like, when you see like something really unpredictable or like whatever, some really weird shape which you can't really recognize immediately, then your brain actually trying to make kind of some line actually, and then it transforms to or whatever, finding the closest shape which you already know. This is kind of some our brain is like developed for, because we have to survive in the nature, because when we are in caveman, actually, when you see whatever something is moving or something, anyway you have to predict it. Is it tiger? Then you are gonna dead, and if it's kind of some small thing, then you have to catch it. Anyway, so this story was like everything started from this story. Actually, like it was a really great story that our brain actually making some fake thing actually. So this is kind of some start of all my kind of some concern point of when I start kind of some artwork. So like our brain, we human actually, we really hate kind of some, which is some situation over whatever we can't really control everything or we can't really predict something. So when we come back to our project, then then first actually what I really want to try to make kind of some this laminar flow is like I actually found some really cool thing from the YouTube actually really long years ago, which is kind of some ion wind. Probably many of you already got this video or something in YouTube. So basically it's super simple to say that like if you prepare kind of some two conductor, let's say metal and metal, whatever. And then when you give kind of some electricity in one side, then you have to touch each other, right? And then these electronics actually go to the next conductor and pass through. But actually, even you didn't touch each other, so let's say in between this conductor, there is the air. Air is also kind of some material, actually. Every material, you can actually pass through the electricity if you have enough voltage, actually. So simply to say then, like if you just give like really high voltage, like 50 or like 100K voltage, then like even air actually you can actually pass through this electricity to the other conductor. And then like during the process actually like the kind of some it actually hit the physical air, and then it just makes some physical air. And so usually, like it already you can find it in kind of some YouTube, like making kids toy or something, because it's really super low efficiency. How can I say, like so all kinds of energy you spend for this one is like it doesn't really make like enough velocity of the wind actually if you compare with our traditional way of the turning fan or something like this. But like NASA is like still like focus on this technology for finding some other way, alternative way of the moving the spaceship in the air, because like there is no air or something. I really don't want to go too deep the story, but then actually and so 2023 actually I was really deep into this technology, and then I try following all kinds of research, and I just did a lot of tests, and then as you see then this tiny like the violet thing is like baby plasma. It's super cute and super dangerous. If you touch it, and it's really hot. And I actually already had a lot of some accidents during this test, and like I actually started from like the 1,000 voltage, and then like 5, and then 10K, and then 50K. In the end, I actually reached 100K, and then I touched every fucking voltage actually by myself, because I have to know it is really dangerous, because and. But luckily, so like the current is super low. It's like really micro ampere or something like this. So it's super hot, but it doesn't really have the power to pass through all your body, but it just just burn tiny bit of your skin. So still safe. Just for your information for the future. And then I made some tests actually. Like I just really want to quickly show you. I don't know, is there is sound coming up? So basically, like this conductor is like really bad video for explain, but as you see, then there is kind of some nail and kind of some this round thing. This conductor is like prepared to making kind of this ion in actually each other. But the thing is, if you see kind of some plasma, it means it failed actually. So this ion wind only generated by just before when it starts to make the plasma. So this is why like I always have to like really control the voltage and current really sensitively. And then the other example is, this is plasma, which it shouldn't be there. And then what happened is this plasma is like happened too much or too suddenly, then like it actually makes the effect all kinds of electronic devices nearby actually. So this is the EMI, electronic magnet I forgot the word, I can show you later. But anyway, but during all this test actually, somehow I know that how I could deal with this one, and I have all kinds of number, which I have to set kinds of this voltage, current, and everything. So I didn't really focus on this one. That was my mistake, really biggest mistake. And then I just jumped to the next step. I just prepare all kinds of conductor shape and combination between them, which one is the best. Because the thing is, there's no reference what is the best the conductor shape, or there is no reference. All kinds of this ion, this thing is like on the YouTube is just like, still some kinds of YouTuber also trying to make their own awesome ion wind, but there's no rule actually. You have to figure out actually. And then actually I found like really one kind of some ion wind generator company in Taiwan actually. And then, but they actually made this ion wind device actually for some company's air filter thing or something. And it's a really funny story because many of the Westerner, the research actually, they already noticed that like this, some air filtering by this ion wind, actually doesn't make sense at all. There is no effect, but like still some Asian actually really believe that like, it works or something. Anyway. So he was almost the only one guy I can actually ask, send some question about this, and then, all right, okay. And then I just sent all the questions, and he was super friendly. He really wanted to help him, but the thing is he didn't speak any English. We always have to translate everything. And then when I just sent all kinds of technical questions, then most of his answer was like, I can't really calculate it. I can't really give you the number because, I know what it is, but I did this 20 years. But I can't really explain. So just, start with this number or something like this. So actually, I still don't have really logical calculation. But in the end, so many tests actually, I got kinds of my own number for this project, and all kinds of shape. And I actually check all the velocity every time by myself. Yeah, and then it's kind of my first type of the version of this the artwork, and then all kinds of calculations, structure design, blah, 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 blah. And then it was really pain in my ass, and kinds of conductor part, and unique assembling, and this is a high voltage generator which costs really a lot, and I burned it 2 times actually. All of the unit part. And then the first exhibition was happening in Korea. Actually, I have to bring everything to Korea. And then, but the kinds of this metal frame, I couldn't bring to there. So I just found one Korean manufacturer and asked to build it actually. And then, unit assembly, blah blah. Okay, so from this part actually, really sadly, I don't have so much video or images for you guys. I have to tell you just what happened by the story because. So the thing is, when I actually bring everything and then start to install on the site, like this Ars Electronica, there was really huge the site actually, there were like 20 artwork like me, and then like suddenly when I turn on, then like all the devices nearby me, like kinds of 10 or 15 meter monitors gone, LEDs blinking. Seriously, all the wireless connection, like the Wi-Fi, everything is gone, and it just turn on again. So like no one really see. So I actually called all kinds of professors in South Korea, and then like all the answer is like, only I can say is because of EMI, but it's so in the end actually, so what we figure out is like high voltage generated plasma, but I thought that I could actually figure out, but then actually this spark actually continuously generates kinds of this EMI here, electromagnetic interference, which you never really want to know in your life actually. And then the thing was, the expert expected was like, because of this metal structure, what I built was basically work as kind of some antenna actually. Yeah. So it actually happened that it, like amplifies all this thing, and then like it actually, shut all this EMI to the everywhere. That was the only one hypothesis actually. So sadly, like I really have to, the next day was the opening. So like, I just like asked to one of my best friend, like genius touch designer guide, and like, okay, I really need to do whatever, something. So like, just build kind of some sound and video which, just showing the people and this kind of my concept. And then he actually built this awesome thing within 30 minutes. And yeah, so this is my like first most worst experience ever in my artist life, like, because this budget was like, they actually, all the budget and everything 1 year built, and then in the end, like just 1 day before the opening, it just happened. Yeah. So then actually, like, I was really, crying in my room, blah, blah. And then, like, next year, I really wanted that, okay, I really have to recover this shit. Otherwise, all my career is done and blah. And then I just choose that, like, okay, maybe I have to go to really safest and easiest way, which is kind of some, okay, generated laminar flow by old school way by the fan, actually. And then I actually had to run this, the CFD simulation software, which is actually kind of some you can calculate the kind of some what was it? The English word, the fluid dynamics actually. And yeah, I mean, let's pass this one. We don't have time. And then like first, actually, I think that really easily, yeah, just make something like the Dyson fan actually. And then the problem of this Dyson fan was actually, it's that the Dyson fan is just building for only something empty, no fan inside, that's it. It doesn't like really design it for kind of some, some even airflow or something like that. So, and that is why like I actually go to the much more simplest way. Okay, just make it all the kind of some, devices all each of the part and control each of the part. So using many of the micro fan inside and control every these pieces. And then when I just make some simulation of this 24 fans design per each of the unit, and so simulation result was really amazing actually. I could actually control each of the direction or curve and inside and outside everything. And yeah, and then, sorry, it suddenly really jumped to here, but yeah, and in this so last year winter actually I got some second budget to rebuild everything actually. I found like really good some art organization and to hold this story that how I can fail and why I should actually make it in the end actually. And then yeah, sorry, this is the suddenly, like, all the kinds of presentation goes too fast, but yeah, this is how I finally built up the second version. So, yeah, that's a great, thank you so much.
Amazing, team. Thank you for sharing this journey. Are there any questions? No?
So the question was, I have to repeat this because for people who are not here, they don't hear you. So the question was that did you finally build it with fans, right? And
yes, actually, like because like A is that thing is to.
Could you talk to the microphone, please? Thank you.
Sorry, yeah. Also the main reason is like not only for this artwork. What I learned in this time is like the most biggest mistake on myself is actually I actually choose a technology not what I really want to show it actually, At the beginning, like the reason I choose this ion technology thing, to be honest, like, I really want to do something special. Really, to be honest with you guys, there are a bunch of media artists and especially they are based kind of some engineering or programming side, nerdy like me, like Simon. Sometimes we, sometimes we make some mistake like this way. We need to be special. We can't really use some skill technique which the other artists already use or something like that. That was happened on me, and in this time, when I just get it fair, then I realized that that's really not important at all, actually. No one really care, actually. People always care about, in the end, like what you really want to say and what you really want to think in, not kind of some your technique or skill, actually. So I'm quite happy that like making this artwork, but more happy that like I learned really important thing in this time. Yeah. Thank you.
Okay, thank you so much. Thank you for staying here. We are 5 minutes over time, but I think that is really good, I guess. One more time, thanks to everybody who presented here. That was amazing. Thank you for sharing your work, and it is a very valuable moment to be here to see all these experiences and seeing you and hearing from you. Thank you, Simon. When he mentioned that, hey, let's make a meetup during Ars Electronica, I was like, man, we have like 600 things to do. Like, not another one. And I was thinking that maybe we cannot make it, but I really am happy that we did this. Thank you to Ars Electronica for giving us the space to be here. And thanks to Maxim, he just joined to see the festival, and now he's doing a live stream, and this is really a difficult job. You want to have OBS, microphone, Zoom, and all those things, and making sure everything is on YouTube, etc. I wouldn't be able to do that. Thank you so much, Maxim. And the very last thing, if you want to see how deep the rabbit hole goes, 1st of October, we start with the beginners workshop. 1st of October, Chris? Sometime end of October. If you want to see how the deep rabbit hole goes, you can start your journey from there. VVVV.org is still always a place that you can get connected to the community, and share the love, stay curious, and have a good patch. Thank you.
I just want to say quickly, thank you, Simon and Amir, for putting together this evening. Thank you very much and organizing this. Yeah. And I heard there's a tour tomorrow. Can you share some insights about this?
Oh yeah, maybe Rosie knows more, no?
I'm also giving tours as part of the festival team in the Post City, and I want to offer one for tomorrow for everybody from like a VVV community event. I will take care of the main floor of Post City tomorrow at 2 o'clock, and I will be really happy if the artists exhibiting in the bunker would help me with the tour part downstairs. Yeah, okay, cool. Thanks to VVV, we got some beers and some snacks outside. Grab them, and then I think we have to leave here, no? Yeah, at some point
we have to leave until 9. Yeah.
And I have heard that this elevator is